Okay. So, hi everyone, welcome to the Student the Brand. Now we will discuss about grouping of cells. So, before discussing grouping of cells, now we will discuss about resistors are connected in series and parallel. First, we will discuss resistors are connected in series and parallel. After that, we'll go to the grouping of cells. So, by comparison, it will be easy to understand. So, if we compare, it will be easy to understand. That's why I will explain first resistors are connected in series and parallel. After that, we'll go to the grouping of cells. Okay, listen carefully. So, if resistors are connected in series, so I'm taking 1 and 2 and 3. So, like this, I'm taking. So, ammeter, like this. So, here cells. So, R1 and R2, R2, R1, R1, R2, and R3. Okay, R1, R2, R3. So resistors are connected in series and resistors are connected in parallel if you take like this. So here I'm considering the battery like this. So now first we will discuss resistors are connected in series, resistors are connected in parallel, then after that we'll go to that. So resistors are connected in series, resistors are connected in series combination series. So now you can observe here, this is the R1, R2 and R3. So this is the battery. Positive terminal, negative terminal, current is flowing. Okay, across R1, V1, across R2, V2. Across R1, V1 I am taking here, V1. And across R2, V2. And across R3, V3 I am taking. So like this. 3 resistors. So 3 voltmeters I connected. If it is connected in series combination, okay. So what is the formula? The formula is resistors are connected in series combination. Okay. Now you can observe here. So from Ohm's law, V equal to IR I am taking. V equal to IR from Ohm's law. Now potential difference is different. V1 plus V2 plus V3. So that's why I'm taking IRS equal to IR1 plus IR2 plus IR3. So I'm taking I common. Anyway, current is same. So here IS equal to I1 equal to I2 equal to I3 equal to I. Because current is same in the circuit. So if resistors are connected in series combination, current is same. The physical quantity which is constant in series combination is current. The physical quantity which is constant in series combination is current. So current I am taking now. So we can take I common. IRS equal to I am taking common R1 plus R2 plus R3. So I get cancelled. So the final formula is RS equal to R1 plus R2 plus R3. So this is about resistors connected in series combination. Final formula is, so you can see the final formula. RS equal to R1 plus R2 plus R3. If resistors are connected in parallel combination, so now you can observe here. So like this I am connecting like this. So ammeter here I am taking. So battery, positive terminal, negative terminal, current is flowing. And here R1, R2 and R3. So 3 resistors are connected in parallel combination. So across These three resistors are connected. Now you can observe. So voltmeter is connected. Here is the voltmeter like this. So I1, I2, I3, I1, I2 and I3. I1, I2, I3. So current is divided into three parts. Now you can observe here. From Ohm's law, V equal to IR, then I equal to V by R. Okay. So IP equal to I1 plus I2 plus I3. We can take IP equal to I1 plus I2 plus I3. Okay. So then V by RP equal to V by R1 plus V by R2 plus V by R3. So shall I take V common? 1 by RP equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R2 plus 1 by R3. So VB get cancel. VB get cancel. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here you can observe one thing. If n number of resistors are connected in series combination, so RS equal to NR, right? So if n number of resistors are connected in parallel combination, so RP equal to R by N. So this formula we will use, and this formula also will use. So you have to observe carefully. So observe carefully, this formula we will use and also this formula also will use. So that's why I am explaining now. Okay, so keep in mind these 2 points. So now we'll go to the grouping of cells. So make sure that these concepts are there in your mind. Okay. So just for comparison, it will be easy. Now we'll go to the grouping of cells. So now grouping of cells we'll discuss. Grouping of cells. Grouping of cells. Grouping of cells. Okay. Now you can observe. Now you can observe here. So cell, internal resistance, cell, internal resistance, cell, internal resistance. EMF of the cell is E and a small internal resistance EMF E or E and R. So all these cells are connected in series combination to the external resistance. So this is the external resistance, capital R. Okay, external resistance, capital R, right? Yes. Now you can observe. So current is start flowing like this. We know that. So I equal to net EMF. Net EMF by net resistance. Net resistance. This is the formula. Net resistance. So if you want, I'll write it for your sake or net resistance. Net EMF. Net EMF by net resistance. Net EMF by net resistance. Okay. Now, here you can observe what is the net EMF. So, number of cells. If n number of cells are connected, the net EMF is NE by net resistance. So, we need to identify the net resistance. So, what is the net resistance? Net resistance. Okay, net resistance is, so internal resistance, n number of cells are connected. So as I said in the previous case, if n number of resistors are connected in series combination, we are taking NR. Here also we have to take NR. So net resistance we are finding, net resistance is, so NR plus capital R. So total, so external resistance also we need to add. Okay, so total I equal to NE by NR plus capital R. So this is the current. Okay, so I hope it is clear to all. I hope it is very clear, right? Yes. Now, if cells are connected in parallel combination, how to do it? Just check once. So if cells are connected in parallel combination, if cells are connected in parallel combination, now you can observe here. Cells are connected in parallel combination. One, so internal resistance, and here also two, internal resistance, and next one three, internal resistance. So here this is same EMF and same R. R is same for each cell, and EMF also same for each cell. Now, so that is connected in parallel combination. Now, those cells are connected to external resistance R. So current is flowing. So now you can observe here all positive terminals of cell connected to one side, all negative terminals of the cell connected to another side. Okay, so one point here, so we can take one point. All positive terminals of the cell is connected to one point, all negative terminals of the cell is connected to another point. Okay, so now you can check here. You can check here. So EMF is E only. Net EMF is E only. Okay. Net resistance, net internal resistance. Be very clear. Net internal resistance. So in the previous case I explained, right? If cells are connected in parallel combination, so n number of cells are connected in parallel combination, the formula is R by N. So that's why I explained. That's why I explained before itself. Now, so I equal external resistance, net external resistance is R only. Net external resistance. Net external resistance. How much? R. Total resistance is total resistance. Total net resistance. Total net resistance. That is, so R plus R by N. R plus R by N. Now we can take anyway, current is flowing like this. So here and here and here, right? So current is I and here also I. So now I equal to net EMF by net EMF by net resistance. Net resistance. Correct? So now net EMF is E by, so net external resistance is R plus R by N. So I equal to E by R plus R by N. So this is the answer. This is the answer. I hope it is very clear. Okay. So just check once. So this is the parallel grouping of cells. Parallel grouping of cells. Next I am going to that. So different EMF and different internal resistance, if you connect in the circuit, then so what is the total current? So we'll see now. Okay, so now EMF is different, internal resistance is different. If you connect, so cell, internal resistance, so different internal resistance, different EMF. So I'm connecting like this. So this is the capital R, total resistance, capital R. Here is E1 and R1. Here is E2, R2, E3, R3. So current is start flowing. So here, and one more thing, even though different EMF, different cells for different EMF and different internal resistance, still, so all cells positive terminals are connected to one point and all negative terminals are connected to another point. Okay, now so you can observe here. So now we have to apply Kirchhoff's loop. If you apply Kirchhoff's loop law, so how you will get? So EMF is positive or negative. I already explained Kirchhoff's laws. So once go through that. Okay, so check here once. So we need to apply Kirchhoff loop law, right? Now EMF is positive in this case because we are going. So in this way we are going like this. This is the path. So current also flowing like that only. So in the circuit, E1 minus, so through here I1, I2, I3. Okay. Now I1, R1 minus. So total current is I. Here also I. Total current. Okay. That is IR equal to 0. Equation 1. Coming to equation 2. So EMF E2 equal to I2 R2 minus IR equal to 0. Equation 2. And E3 minus I3 R3 IR equal to 0. Equation 3. From equation 1, can we write like this? From equation 1, E1 minus I1 R1 minus IR equal to 0. So this is the equation 1. From equation 1 I am writing. So you can take this side. That is I1 R1 equal to EMF minus IR. Okay, so we can also write like this. So I1 R1 equal to minus IR plus E1 EMF 1. Now you can take, so I need I1. So I1 if you are considering here, okay, so place is not sufficient. If you do like this, I'm doing like here. So from here I am taking I1 equal to minus IR by R1 plus E1 by R1. So simply I am taking, okay, I am writing I1. So this term, R1 term, I am taking to that side, right hand side. So left hand side. So we can take, this is LHS and this is RHS. Okay. So I am taking R1 to RHS side. Now this is the equation. So like this we can write. So already you mentioned equation 1, just you can keep like this. So similarly we can write equation 2 also. So equation 2 also we can write I2 equal to minus IR. IR is same. So net resistance is same, total current is same. That's why I am writing I2. So very easy, very simple. If you follow, it will be good. So you will get in easy way. So I R2 plus E2 by R2 and I3 equal to minus IR by R3 plus E2 by R3. Simple, very easy. Once again I will explain, listen carefully. So different EMFs and different resistance. Okay. So all positive terminals of one cell connected, or positive terminals of the cells connected to one point and the negative terminals of the cell connected to another point. Okay. So current is flowing, that is connected to external resistance R I am taking here. So by applying Kirchhoff's loop law, so EMF is positive because we are moving to negative terminal to positive terminal. Negative terminal to positive terminal we are moving, right? So when you are moving from negative terminal to positive terminal, EMF is positive. And the second point is we are going through the resistor. In the direction of current flowing. That's why minus I1 R1 minus at the same time here also. Through the external resistor. So we are moving in the same direction of current flowing. That's why IR term is also negative. Total external resistance. That's why I capital I minus capital I into R. Sir, why you are taking capital I? Because so I1 plus I2 plus I3. So total current will be added and net current is flowing through R. Net current is flowing through capital R. Capital R is the total net resistance, external resistance. This is external resistance. R1, R2, R3 are the internal resistance. Okay, R1, R2, R3 are internal resistance. So R is the capital R is a net external resistance. Okay. So that is the reason. So as we have to apply for capital R at the same time for internal resistance also. Okay, that's why I'm taking like this, E1 minus I1 R1 minus IR equal to 0. Like that, similarly we are writing 1, 2, 3 because same format. And coming to this, so from equation 1, I am taking I minus I1 R1 term to that side. So we need I1, I2, I3. So that's why from equation 1, 2, 3, I am writing I1, I2, I3. So you can add now. So as I mentioned, LHS side and RHS side. All LHS side you have to add and all RHS side you have to add. Okay, after adding, what you will get? So you can see here, I1 plus I2 plus I3 equal to, now, so here in these terms 1, 2, 3. So in these three terms we can take IR common. Minus IR term I am taking common. 1 by R1 plus 1 by R2 plus 1 by R3. Okay, plus here, so E1 by R1 plus E2 by R2 plus E3 by R3. Okay, now? So now, so this term I am taking that side because this total term will become I, that is net current. So total current, so that I am taking. So I equal to, so this term will become plus IR. Now we'll get 1 by R1 plus 1 by R2 plus 1 by R3. So this total term we can take sigma E by R. This also we can write instead of writing this complete one, because for understanding I wrote. So you can take this complete one, sigma. So in this format, sigma 1 by R we can write. This complete terms we can write sigma 1 by R. So here sigma E by R. So in these two terms we can take I common, 1 plus R. So here this one is sigma 1 by R. So sigma 1 by R, sigma 1 by R. So if n number of resistors are connected, as I said, so this one we can take. So this one, sigma E by R. Okay. Now you can observe here. So observe carefully. So very simple. Almost we reached the final step. So we can take this side. So divide numerator and denominator with sigma 1 by R. So numerator and denominator with the sigma 1 by R. So I'll get the final equation. Final equation will get it. So I'll get the final equation. That is I equal to E equivalent by R equivalent. Okay, so that's enough. So anyway, E by R plus R by N. So this is the formula, final formula. Anyway, whatever you are getting for a parallel combination, the same format you will get it. Okay, so here this is the R. Understood? So listen carefully, observe carefully. So very easy, very simple. So just you have to follow. So easy steps, very easy steps. So we need to follow the step-by-step method. So then finally you'll get the answer. Check once here. So different cells are connected. Okay, 1, 2, 3. So this EMF, okay, E1, E2, E3, different cells, different EMF and different internal resistance. Current is moving. So here from equation, so we need to apply Kirchhoff's loop law. So that's why positive EMF minus I1 R1 minus here. So through current I also it's going, right. So we can take I value here. I value, IR term, that is negative because in the current direction it is flowing. Okay, so by that 1, 2, 3 we can write. So IR terms we can take it out, and I1 value you need to write. Then you can add all LHS and RRHS. So LHS side, so total current. So this term you can take that side, I you can take common and do this, you'll get the final answer. Okay, check once. Check once. Okay, so I hope it is very clear. And so change the cell. So reverse the cell here. Second cell you can reverse and do the same process again. And LHS and RHS side. Then you will get the values. Okay, so I hope it is very clear to all. So if you like the video, if you like the content, if you like the explanation, if you like the channel, so please do like, share and subscribe to Student the Brand. This is our Seva sir from Student the Brand. Thank you so much for joining and attending, listening my class. So we will see you in the next class. Thank you.